Let's consider the following problem. Consider a circuit with resistor and inductor and capacitor connecting in series. At time t equals 0, charge Q0 is on the capacitor. Whether the charge Q is a function of time. Alright, so this one's a little simpler problem, believe it or not. Okay, you have a Q, you have an inductor here, and then you have a resistor. Okay, plug it in. This is C, this is L, this is R. What is charge Q as a function of time? Alright, let's use Kirchhoff's law again. Basically, cross this capacitor, I'm going to get minus Q over C. Cross this inductor, I'll get minus L di dt. Cross the resistor, I'll get minus I R equals 0. Okay, of course, assuming I is going like that. Alright, so if I have this set up here, let's basically figure out what these terms are. Note I is equal to dq dt. So I have basically minus q over c minus L d squared q dt squared minus R dq dt. Alright? Or written more compactly or in more familiar notation, of course everything equals 0. This is going to be equal to L dq squared dt squared plus minus R dq dt minus q over c equals 0. Alright? Okay, so I'm going to divide by L. Right? I can do that. Divide by 0 divided by L is still 0. Okay? And so I have this equation, right? And I'm going to guess the solution and check it, right? But we know what this is. This is just this damp simple harmonic oscillator. We know what the solution is going to be ultimately, but let's just go through it. Okay, so we're going to guess Q is equal to some A exponent I omega t. Plug this in now, alright? So plugging in, I get basically the first term I will get a minus omega squared A exponent I omega t. Second term I will get a minus, minus, a minus is a plus, plus this was be minus I omega R over L A exponent I omega t. Last term it will be minus Q, whoops, sorry, minus 1 over LC A exponent I omega t. Okay, everything's equal to 0 now. Okay, so now the beauty of this is that these terms all go away. In fact, the a's go away too, right? And you're left with basically a quadratic equation for omega, which is omega squared minus I R over L omega minus, I'll call this omega 0 squared is equal to 0, where omega 0 squared is equal to 1 over L C. Okay. Okay, so where was I? Alright, so this is our simple quadratic equation. We know how to solve quadratic equations. Basically, we have omega is equal to minus b, which in this case is going to be minus, which is plus I R over L plus or minus the square root of b squared, which is r squared over L squared, times I, which is be a minus sign, plus or minus 4 AC, so it's 4, A is 1, C is minus omega squared, so it becomes a plus, square 0, divided by 2A, that's a 2, okay? Now, the key, alright, to recognize, to basically doing this, is to recognize that this is to basically assume that omega naught squared 4 omega squared minus r squared over L squared is greater than 0. Okay, so this thing is going to be real, and so basically then you have a real part and imaginary part. Okay, And so what you end up getting is that basically omega is equal to, I'm going to put the 2 in there to make it a little clearer. This is going to be omega naught squared minus r squared over 4 L squared, and then basically it'll be plus or minus this, signifying there's 2 possible phases associated with this thing, and make sure I get this right, plus a I, okay, r over 2L. Okay. Now, so this is the exact expression, and so when we plug it back into here, okay, what we're going to get is that we're going to get Q is equal to A, right, whichever A is, exponent I, we'll brace it first, square root of omega naught squared minus r squared over 4L squared. I'm just taking one side for now. You could take the minus sign there if you want as well. Plus I r over 2L times T, okay, which I'm multiplying this thing out is going to give me an there's a I times I is a minus, so it'll be exponent minus r over 2lt exponent, right, I square root of omega naught squared minus r squared over 4L squared times t. Okay, and now since that t equals 0, this is charge q is q0, you can show this is just q0, and there is your solution as a function of time. Hope that was helpful.